Yeah, 1 second. Yeah, yeah. Good evening, all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in this Hadoop and big data environment. So as part of today's demo, I'll be covering the following things: what is big data, why Hadoop, drawbacks with the current databases, Hadoop advantages, Hadoop scope and job market. Apart from that, I also discuss about Spark with Python implementation, right? By Spark. Yes. So big data, the name itself saying like huge volumes of data, right? It's saying like huge volumes of data. So currently how the data is getting stored like KBs, MBs, GBs, terabytes, petabytes, exabytes, zettabyte, etabyte, and sotabytes, right? Should have seen KBs or MBs or GBs of TBs of data. You have seen this MBs, GBs or TBs of data. But beyond that, you've got petabytes of data is getting generated today. Examples of petabytes of data generation. Examples of petabytes of data generation, right? Yes. Examples of petabytes of data generation, right? So today, if we talk about the social media like Facebook, Twitter, all this, they're storing huge amounts of data, not in GBs or in TBs, petabytes of data. We have got many applications which are storing data in petabytes, like Google, Facebook, Twitter, YouTube, YouTube videos upload, right? And what is the data generated by Facebook in a minute? Each and every post and video, it has to be stored, right? So the data generated by Facebook in a minute, it's petabytes of data generation. Google, Google queries or YouTube videos upload or Gmail messages, right? Yes. All this, they are storing petabytes of data. They are storing like petabytes of data is generated, right? For these things, right? Currently, we have got databases like Oracle, MySQL, DB2, SQL Server. We have got Oracle, MySQL, DB2, and SQL Server. These are used for OLTP, online transactional processing. But we have got specialized databases like if you talk about specialized databases like Vertica, Netija, Vertica, Teradata, all this they are used for data warehouse purpose. But if you talk about these databases or specialized databases, they can handle data up to some extent. But unlimited data storage is not possible in any of these, right? Yes. So for as a solution to all the storage level problems and processing level problems, we have got Hadoop. We have got Hadoop, which is meant for both storage and processing. We have got Hadoop for both storage and processing. For storage HDFS and for processing MapReduce or Spark. And for processing MapReduce or Spark. So if you talk about any technology, it performs either storage or processing. If you talk about any technology, right, it may performs either storage or processing. But Hadoop performs both storage and processing. If you talk like C, C++, Java, all this, they are meant for processing. You see, like Oracle, MySQL, DB to SQL Server, they are meant for storage. So either for they are used for storage or for processing. But Hadoop combining both, right? It is storing and processing. For storage, does Hadoop use any databases for storing its data? Saying like there are many drawbacks with the current databases. We have got some drawbacks with the current databases. Despite of this drawbacks with the databases, still Hadoop doesn't go with databases for storing its data. So it is going with a kind of file system called Hadoop distributed file system. And for processing, we are going for MapReduce or Spark. Spark, very high speed processing technology where it is going to process huge data in quick time. So I'll be briefing about that Spark also, right? Today. Now, Hadoop is meant for, you may ask when Hadoop is performing both storage and processing, you may ask a query. Then why again these processing technologies and storage technologies are used when Hadoop is performing both storage and processing? Hadoop is meant for batch applications. Hadoop is meant for batch applications. Hadoop is not for online applications. Hadoop is not for online application. Hadoop is meant for batch applications. What if there are two types of applications? See, observe there are two types of applications. Two types of applications, right? Online applications and batch applications. Online applications means user interactive applications. User interactive applications means user interactive application means user gives the input. Talk about an online, if you're making an online transaction, online money transaction, compulsory you has to give the input, right? The source account, destination account. Compulsory user should give the input there. All the online applications, user compulsory, he is going to make the transaction without user, right? So here user gives the input. Booking a movie ticket, making an online transaction. Booking a movie ticket, making an online transaction. Batch applications, right? Batch application, user non-interactive applications. Batch application means user non-interactive applications. User non-interactive applications. Here user is nowhere required. Means for example, credit card statement generation for millions of customers, here where user is nowhere required. Railway ticketing PNR status, your waiting status is 200 now. After 1 hour it became 150. Tomorrow morning it became 100. Tomorrow evening it got confirmed. Here user has nothing to do here. Everything happening in the background in automated fashion. So most of these banking applications or financial applications are batch applications. So user nowhere required. So millions of batch applications, right, which involves like millions and trillions of records. We're making a single transaction now. No need of see Hadoop. Hadoop is good for huge data, large data. Hadoop is bad for small data. For one record or two records or 10 records, you'll go with the databases itself. For huge data only, like Hadoop will be useful. It is good for that huge data. We can see the speed. If you can see the speed of Hadoop, if you see huge data and compare, then only you can see great speed for Hadoop and Spark. And we may get why databases are not used for storing Hadoop's data. Why there is a separate file system, Hadoop distributed file system. I'm saying like there is a Hadoop distributed file system. There is a Hadoop distributed file system, right? And why databases are not used for storing its drawbacks with the current databases. Observe the drawbacks with the current databases. First thing is very less storage in most of the databases, very less storage. Unlimited data storage is not possible in the database. And no parallel processing in most of the databases. In most of the databases, no parallel processing. And if volume increases, speed is decreasing, right? As volume increases, speed decreases. Select a total amount from sales one. Select a total amount from sales one. It has got 10 records. Select total amount from sales 2, for example, 10 lakh records. Select total amount from sales 3, 10 crore records. Observe this if you want to check as volume increasing, speed decreasing, right? Now try to respond for this. I'm writing an SQL query, total amount from sales 1, which has got 10 records. Total amount from one more table, sales 2, which has got 10 lakh records. One more table, right? Sales 3, which has got 10 crore records. So here, which query is going to execute faster among these three? Which query is going to execute faster among these three? Obviously, the first query, right? Obviously, the first query is going to execute faster among these three. Compared to that, see this first record executes faster as compared to the remaining two because total amount of 10 records compared with 10 lakh records or 10 crore records. The first query is going to execute faster as compared with the remaining, right? So as volume increasing, speed decreasing. And one more drawbacks with the databases. Complexity increases, speed decreases. If complexity increases, speed decreases. Total amount from sales fund. Similarly, average amount from sales fund. Standard deviation of amount from sales fund.
Maximum amount also.
Okay. So here, okay, total amount from sales fund, average amount from sales fund, standard deviation of amount from sales fund. If you observe these three queries, which query is going to execute faster among these three? Yes. See, this average amount is a two-step process. Average amount is a two-step process. Average amount is a two-step process. First sum to be calculated. Next average to be calculated as compared to the first query. Second query takes more time because it's a two-step process. As compared with the third one, standard deviation of amount. Standard deviation of amount, right? Lot of internal processing is required. Lot of internal processing is required, right? So compared with the first query, second query, third query takes lot of internal processing. So query to query, even if complexity increasing also, speed decreases. But the major drawback with the databases, they can handle only structured data. They cannot handle unstructured or semi-structured kind of data. They can handle only structured data. They cannot handle unstructured or semi-structured data. For example, just check this. If I'm writing a query like this, for example, I want to take reviews for a particular movie. Data is in a structured format. Data is in a structured format. Just user and the review. User 1, user 2, user 3. In this way, hundreds of users giving this reviews. If the movie is good, saying 1. If the movie is bad, saying 0. If the movie is good, saying 1. If the movie is bad, saying 0. Saying the reviews in the form of ones and zeros. Can you write an SQL query to count the number of goods and not goods? Number of ones and zeros. Number of ones gives the goods. Number of zeros gives that. Can you write an SQL query to count this? Count aggregation. Single grouping, single aggregation. Select single grouping, single review wise. Count I want from a reviews table. Group by review. Select review wise count from reviews. Group by review. How many ones and how many zeros? 90 people saying the movie is good. For example, assume 10 people saying the movie is bad. Means this is the output you got. How many ones? 90. How many zeros? 10. But generally, reviews won't be given in the form of ones and zeros, right? They'll be providing in their own text format. First person saying movie is good. Second person movie saying movie is not good. So in their own text format, the reviews will be given. Now, can you write an SQL query? Can the databases handle this kind of data? They're giving in their own text format. Movie is good, movie is not good. Now, can you count the number of goods and not goods here? Even if you say, even if you try to say, okay, even if you try to write by using this keyword count, by using this keyword count, if you try to perform, it gives wrong computation because even not good has got good in it. So the wrong computation, wrong count you get. So this kind of data can't be handled. This kind of data can't be handled, right? So databases can handle only, yes. Databases can handle only structured data. They cannot handle this kind of data. Very less storage, no parallel processing. As volume increases, speed decreases. Observe this. Query to query. If complexity increases, speed decreases. Databases can handle only structured data. So these are the drawbacks with the current databases. So despite of these databases, Hadoop going with a kind of file system called as Hadoop distributed file system. There's got Hadoop distributed file system. Before I go with this, Hadoop advantages, before I go with the Hadoop advantages, right, you need to know something about this Hadoop architecture. Hadoop follows master slave architecture. It follows master slave architecture, not client server architecture. Not like request response architecture. Whenever you give request, immediately giving response, that kind of architecture is not. Master slave. Single master and multiple slaves. Single master and multiple slaves. Master. These are the slaves. Single master. This we call it as a cluster. We call this as a cluster. Cluster. A cluster, right? Group of nodes connected in a network. Group of nodes connected in a network. Group of nodes connected. One will be that master. Remaining all will be the slaves. One will be the master. Means group of systems. Group of CPUs connected in a network. One will be the master. Remaining all will be the slaves. How the data is stored here in Hadoop? In the form of files. The form of files. f1.txt file. Assume each system you got 1 TB, 1 TB storage, 1 TB storage, 1 TB storage. You got 1 TB storage, but the file size is 2 TB. This 2 TB file cannot fit into any of this system, right? It cannot fit into any of the system. So not like the so this file in Hadoop, if we talk about any data file, will be divided into smaller parts. It is divided into parts. Each part is stored across this. Each part is stored across. Each part is stored across this. Each part is stored across this, right? Yes. Means here two things you can observe. Data is distributed, means your data is distributed across multiple systems, and data is processed by multiple systems parallelly. Here two advantages you can see. Data is distributed and data is processed by multiple slaves parallelly. Two advantages, right? Means any bigger data volume, any bigger data objects, they can fit into this, right? They're divided into parts, and each part is stored across multiple systems, and they are processed by multiple systems parallelly. A single file processed by multiple systems. Right? Yes. Okay. So this is the master, and these are the slaves. Your data is stored by the slaves. Data is processed by the slaves. Your data is getting stored in the slaves, and data is processed. So everything done by the slaves. Then what master is doing? Master, right? Assigning tasks to the slaves, load balancing the load. The tasks are equally provided to all the slaves. If any slave goes down, suddenly if any slave is failed, then the task of it has to be assigned to any of the other slaves done by the master. That process we call it as fault tolerance. While multiple tasks are executed by multiple slaves, suddenly if any slave goes down, then the task of that slave has to be provided to any of the available slaves. This process is called as fault tolerance mechanism. Okay, check this. Hadoop doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture. Hadoop follows master slave architecture. Single master, multiple slave architecture. Master node responsibilities. Task assignment, assigning tasks. Load balancing. The tasks are equally given to all that. Fault tolerance. If multiple tasks are executed by multiple slaves, suddenly if any slave goes down, then the task of it will be assigned to any of the available slaves. The process is called fault tolerance, right? Health monitoring. So each and every the status of each and every slave node maintained by the master node. Slave node responsibilities, storing the data and processing the data. So the total storage and processing, everything happens by the slave nodes. Master node just maintaining fault tolerance, health monitoring, load balancing, these things, right? Now coming to the Hadoop advantages. Try to understand this Hadoop advantages. So unlimited data storage is possible. Unlimited data storage is possible because of horizontally unlimited scalability. Because of horizontally unlimited scalability. Horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. For example, today if you are running a business with very less number of slaves, you have got a business, you're running with less number of slaves. Assume that you are running with 10 slaves. Tomorrow your data means your business has increased, your customers have increased, your branches have increased. If data increased by 100 times, if for example, if customers increased by 100 times, data increased by 1000 times, you cannot go with the same number of slaves. Systems horizontally should keep on increasing this. Horizontally unlimited scalability, horizontally unlimited number of slaves can be added. Very high speed processing, you are able to see here, very high speed processing because of a parallel processing, because of parallel processing. Very high speed processing because of parallel processing. Can handle all varieties of data. Can handle, okay, very high speed processing because of parallel processing means, see, multiple systems are executing a single file parallelly. Very high speed you are going to get, right? The work done by a single system, work done by multiple systems parallelly. Because of that very high speed you are going to see, yes. Can handle all varieties of data. Can handle all varieties of data. Structured data, semi-structured data, and unstructured data, it can handle. Hadoop can handle all varieties. Databases can handle only structured data, but Hadoop can handle all varieties. It's an open source. It is an open source. No licensing is required, right? It is an open source, no licensing is required. And commodity hardware. Commodity hardware means Hadoop can run on any hardware configurations. Doesn't mean that it need to have the latest hardware configuration. It can run on any hardware configuration. So these are the main advantages. Mainly these are the three, right? Unlimited data storage is possible. Handles all varieties of data, structured, unstructured, semi-structured. Very high speed processing because of parallel processing. Okay. There was a test done by Yahoo, right? Yahoo conducted a test to check the speed of a different databases. It has taken a table of 100 TB consisting of 1024 columns. The task sorting based on 16 columns. Sorting based on single column does, but sorting based on 16 columns. Time taken by the different databases. Oracle has taken nearly 3.5 days to process this. MySQL has taken nearly 6 days. Teradata, right? handles TBs of data used for data warehouse purpose, taken 4.5 hours. Netija has taken just 3 hours. Netija has just taken 3 hours. Hadoop. Hadoop has taken 3.4 minutes. Hadoop has taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes. See the speed of this Hadoop compared with other things which these have taken days of time. These have taken hours of time. Hadoop has taken minutes of time. Very high speed, right? So Hadoop is proven in the market. Hadoop is proven in the market. Okay, fine. The speed of Hadoop, right? Yes. Now, not only the speed, even storage point of view also it is proven in the market. Even if you talk Spark, Spark has got higher speed than Hadoop. We'll come back to that. Why databases like Oracle can't support unlimited storage? Why databases like Oracle can't support unlimited storage? Why only Hadoop can perform this huge storage? Data for databases also, there is a limit for databases also. They can go with multiple systems, multiple CPUs, but there is a limit, max limit on the number of slaves, number of systems. If you talk about this, Oracle can go maximum with 256. Oracle can go with maximum 256 nodes or CPUs. Beyond that, it cannot support. Once data is filled, it cannot support the data further. Even if 256 systems are filled, even the system will be degraded. The system performance will degrade. It's just like your mobile phone. If 64 GB internal is given, if you are filling all the 64 GB, sometimes the phone even you won't even start. Same way here also. Beyond that, it cannot support. MySQL also it can go. MySQL can go with 54 nodes only. MySQL Express can go with 256. DB2 can go with 256. SQL Server also with 256. But Teradata, it can go with 512, but currently it's going with 1024 nodes. Netija, 1024. Vertica, 512. But even though like 256 or 1024, we cannot say it's unlimited data storage is not possible here. But there is no limit on the number of slaves that Hadoop can have. Unlimited number of slaves, CPUs or nodes. Yahoo, when first time implemented Hadoop, it went with 4,000 nodes or CPUs for storing its data. Currently, it is using 12,000 nodes. 12,000 nodes. Facebook, when first time implemented Hadoop, went with 8,000 nodes. Currently, it is going with 52,000 nodes for storing its data. So Hadoop is proven in the market, storage point of view and processing point of view. With very high speed as compared with other things with huge storage, right? Yes. Now, not only this Hadoop, right? In this course, I'll also be discussing about this Spark, PySpark, Spark with Python implementation. I talk about what is Apache Spark, why PySpark, need for PySpark, PySpark job market. Just I'll take some time. What is Apache Spark? What is Apache Spark? It is a open source, distributed cluster computing system. It is the engine for data analysis, for processing and computation. Why PySpark means it's a Python API to use a Spark. Spark is an open source and it is a lightning. PySpark is the lightning fast technology that is designed for fast computation. It is one of the very demanding tool among the data engineers to work with bigger data sets. It is used for running, PySpark is used for running distributed SQL, for data pipelines, for distributed SQL, you can say, for data pipelines, creating data pipelines, ingesting data into database, ingesting data into database, running ML algorithms, running machine learning algorithms, working with graphs or data streams. See, what is the necessity for PySpark means, right? Huge data is getting generated. This data consists of hidden patterns, unknown corrections, market trends, customer preferences. So which is required to extract that valuable information from this raw data, right? So we need to have some efficient tools for performing these kind of operations. So previously, I don't say that we doesn't have tools. We have tools, but those tools are not that much of appealing, right? So we need to have some scalable and flexible tools. We need to have some scalable and flexible tools to crack big data and gain benefit from it. So PySpark is such a kind, right? Yes. So PySpark is such a kind. Okay. Sorry. So we require some scalable and flexible tools for to crack big data and gaining benefit from it. So PySpark is such a kind. So combination of Python and Spark will be the very efficient way for the world of big data. That's why Apache Spark community came up with a tool called PySpark. Apache Spark community came up with a tool called PySpark. That is Python API for using Spark. Python API for using Spark. So if you talk, PySpark is used in commercial sector for Apache Spark real-time processing, banks and other financial fields. Bank and other financial fields, they're using Spark to retrieve this social media, like customer social media profile. and to gain useful insights which can help in taking the right decisions. And it plays a vital role in fraud detection, in credit risk assessment, in healthcare, in identifying or predicting the patient who is going to face the issues based on that medical reports. Even in the entertainment industry, right? Today, like the popular OTT platform, Netflix using Apache Spark for processing these online movies or web series. Nearly it is processing 450 billion events per day. And even in trade and e-commerce, like Flipkart, Amazon using Apache Spark for advertising and for recommendations, right? In this way, and majority of they're using this Spark today because of its very high speed processing, right? And if you see that PySpark job market, the job market of this, right? If you see, okay, if you see that package for the Spark, the salary package for the Spark, huge packages are provided as compared with other technologies. In the same way, they'll be expecting the technical skills from your side. So if you see in this course, right? Yes, as part of this, it's a package, right? Total big data package where it includes big data Hadoop, big data Hadoop, PySpark, Linux, and Python. These are four things are included in this package. So I'll come back big data, PySpark, Linux, and Python. Just to go to the course content, just a second. Just to go to the course content, 1 second. Yes, check this course content, right? Yes. Big data Hadoop. Introduction. What is big data? What is Hadoop? Need for Hadoop. Sources and types of data. Comparison with other technologies. Challenges with big data. Storage and processing. RDBMS and Hadoop. Advantages of Hadoop. Hadoop ecosystem components. Going to discuss about Hadoop distributed file system. We use a file system, right? What is name node, data node, HDFS architecture, name node, data node, secondary name node, metadata management, storage and processing, replications. Observe this map reduce processing. It's a parallel execution model. Scoop, the scoop, right? SQL plus Hadoop. SQ, the first two characters of this, last three characters of this forms a scoop for importing and export operations from Hadoop to databases to Hadoop, and performing various operations. During this import operations, performing different kind of transformations, filterings, right? Incremental imports. Yarn, yet another resource negotiator. What are the yarn components, yarn products, and the yarn architecture? NoSQL, I'm going to discuss for NoSQL database. For NoSQL database like HBase, random access and schemaless behavior. Hive, I'm going to discuss about Hive. Hive is one of the important component of Hadoop, which is used for data warehouse kind of environment. So in Hive, in brief, in depth, right? Loading like HQL, we got similar to SQL. Hive query language similar to SQL. Hive built-in functions, dating loading data from this local files from HDFS file. Different types of tables, internal, external. Working with unstructured data, working with XML, working with JSON, working with URL weblog data, multi-tables, inserting into local files, UDF, UDAF, UDTF, partitions, single partition, multi-column partitioning, static partitioning, dynamic partitioning, multi-column partitioning, bucketing, indexing, all this, right? So that is regarding Hadoop. Coming to the PySpark introduction, PySpark usage, Spark sessions, Spark context, PySpark RTD computations, persistence options, PySpark core computing, groupings and aggregations, various inbuilt actions and transformations, SQL data frames, how to perform this data frame API, row class, column class, select, collect with column, column renamed, where, filter, group by, join, UDF, flat map for each. So all this with many working examples. We don't need to write huge codings here. No need of writing codes. We have got many inbuilt functions. We'll be discussing all those one by one, right? PySpark SQL functions, aggregate functions, window functions, data and timestamp, JSON functions, PySpark built-in functions, split, concatenate, substring, translate, overlay, date format, explode, array, create map, struct. PySpark external sources working with SQL statements, Spark and Hive integration, Spark SQL integrations working with CSV, JSON, narrow and wide transformations, adding of new columns, dropping of columns, handling nulls, joins, writing back to external sources, deployment modes, local mode, cluster mode, PySpark application, right? Stays drivers and executors building Spark applications, deploying Spark apps to the cluster and tuning, PySpark streaming components, integration with Kafka, and Spark machine learning library. So I'm going to discuss three processing components like MapReduce, Hive, and Spark, and one storage component like HDFS, and one NoSQL database like HBase, and one streaming component like Kafka as part of this. Apart from this, the total Python knowledge is Python is discussed, core and advanced Python, right? Basic Python features, applications, versions, installations, Python operations, data types, constants, variables. Operators in Python, IDs in Python, working with different IDs, integrated development environment with Jupyter, Spider, Eclipse, flow controls, looping statements, strings, collections like lists, list operations, tuple operations, set operations, dictionaries, functions, different types, categories, lambda function, filter function, map function, reduce function, modules, different ways of importing, renaming, reloading, packages, exceptions, file handling, object-oriented programming concepts, regular expressions, database connectivity, installation of one database connecting to the database, date and time, operating system module, iterators, generators, close decorators, graphic programming, Excel workbook, data analytics, reduction to data science, pandas model in brief. NumPy model in brief and matplotlib model in brief. So all this four technologies will be discussed. So big data Hadoop, PySpark, Linux, Python. So these three things, big data, Hadoop, PySpark, and Linux. These three things, these are weekends. It goes for 12 weekends. 12 weekends. Saturday 2 hours, Sunday 2 hours. These three. So the timing of this batch will be from 5 to 7. Okay. And this Python, you can multiple Python batches I'll be discussing, right? You can attend any of my Python batch, nearly like 50 hours, 50 sessions on this Python, 50 sessions on Python core and advanced. So you can attend any of my Python batch from Monday to Friday. Morning and evening batches are available for this. Monday at 6 a.m. there is a batch starting, right? Monday at 6 a.m. there is a new Python batch starting for this. This coming Wednesday at 8 p.m. Yes, there's a batch starting, right? Yes. So any of this, you can attend any of this batch, right? For Python, Monday to it's videos, all you will be getting all the session videos for all this, right? Big data, Hadoop, PySpark. Even if you miss any session, you'll be getting the recorded sessions for all this. Soft copies, clear soft copy of these notes for all. this ever. Yeah. One second. Yeah. Yeah, good evening all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in this Hadoop and big data environment. So as part of today's demo, I'll be covering the following things. What is big data? Why Hadoop? Drawbacks with the current databases. Hadoop advantages, Hadoop scope and job market. Apart from that, I also discuss about Spark with Python implementation, right? PySpark. Yes. So big data, the name itself saying like huge volumes of data, right? It's saying like huge volumes of data. So currently how the data is getting stored like KBs, MB